Okay, so in this video, we're going to look at how to multiply and divide surds. But before we do that, I'm going to go through a few recap questions because I think they will help with this lesson. So here we're going to simplify 5a times 3b times 2c. Whenever we multiply terms, we multiply all the numbers together. 5 times 3 is 15, 15 times 2 is 30. And then we put all the pronumerals together, A, B, C. So we multiply all the numbers together, all the coefficients, and then all the pronumerals. In question B, we've got 12x over 4y. We need to simplify this by cancelling out any common factors. 12 and 4 are both divisible by 4. 12 divided by 4 is 3. 4 divided by 4 is 1. So that leaves us with 3x over 1y. And that's it. We can't cancel out x or y because they are not common. In question C, we're going to expand this. So 3d times 5d is 15d squared. Again, multiply the coefficients. 3 times 5 is 15, and d times d is d squared. 3 times minus 7 is minus 21, and then we have our d and an e. Okay, so let's have a look at today's lesson, multiplying and dividing surds. When multiplying surds, we need to use the following result. Root x times root y is equal to the root of xy. More generally, a root x times b root y is equal to ab root xy. Here, we are multiplying what's on the outside of the root sign. So whatever is on the outside of the root sign, we can multiply together. Whatever is on the inside or underneath the root sign, we can multiply those together. Okay, so what's outside goes together, what's underneath the surd sign goes together. When dividing surds, use the following results. Root x over root y is equal to root x over y. Okay, because they are both under a square root sign, we can divide them and then square root it. So more generally, same thing. Use the distributive law to expand brackets. That's exactly the same thing as we did in the first, in the third recap question. So let's have a look at some examples. We're going to simplify the following. Root 2 times root 3, because they're both under the square root sign, 2 times 3 is 6, so it's the square root of 6. Question B, we have 2 root 3 times 3 root 15. So these are the two that's outside the square root sign. 2 times 3 is 6. These are the ones that are underneath the square root sign. 3 times 15 is 45, so it's the square root of 45. Except we can actually split that into two different surds. Because when we think of the factors of 45, we can think of one of them that is a square number. So technically, we can write this as 6 times the square root of 9 times the square root of 5. Because 9 times 5 is 45. Therefore, root 9 times root 5 is equal to root 45. What is the square root of 9? The square root of 9 is 3. Therefore, 6 times 3 is 18. And we have our root 5, so it's 18 root 5. Let's have a look at some division. We have minus root 10 divided by root 2. We can rewrite this as a fraction as minus root 10 over root 2. Because they are both under the square root sign, 10 divided by 2 is 5. So it is minus the square root of 5. Question B. These are both outside the square root sign. So 12 divided by 3 is 4. The 4 goes at the top because 12 is bigger than 3. And here we have 18 and 3. They are both under the square root sign. 18 divided by 3 is 6. So we're going to write square root of 6 at the top. That leaves us with a denominator of 1, which we can just write as 4 root 6. We don't need to write that denominator of 1. Use the distributive law to expand the following and then simplify the surds when necessary. So we're going to expand this. Root 3 times 3 root 5. The number outside of the square root 3 is just a 1. 1 times 3 is 3. Root 3 times root 5, because they're both underneath the square root sign, is root 15. Let's expand this way now. 1 times minus this, a 1 out here. 1 times minus 1 is minus 1. Root 3 times root 6 is root 18. Now, can we split 15 or 18 into two factors where one of them is a square number? Well, it seems like we can't do it for 15, but we can do it for 18 because we can split 18 into 9 and 2. So I'm just going to split that. Into 3 root 15 minus root 9 times root 2. That gives us a final answer of 3 root 15 minus, well, the square root of 9 is 3, so we have 3 root 2. Okay, the square root of 9 is 3. Question B, same thing. Okay, let's expand this. We're going to multiply the 3 and the 2 first because they're on the outside of the surd sign. 3 times 2 is 6. Root 6 times root 10 is root 60. Three times minus 4 is minus 12. What's the square root of 6 times the square root of 6? Yes, we can say square root of 36. But when we multiply a root number by itself, it just equals the number underneath the surd sign. So root 6 times root 6 is just 6. Okay, because the square root of 36 is just 6. So technically we've got minus 12 times 6. Okay, so let's split this off. Here we've got 60. Can we think of two numbers that are, well, one number that's a factor of 60 that is also a square number? I can think of the number 4. So I'm going to split this into 6 times root 4 times root 15, because 4 times 15 is 60, minus 72, because 12 times 6 is 72. What's the square root of 4? The square root of 4 is 2, and 6 times 2 is 12. So we have 12 root 15 minus 72. And that's our final answer. Simplify the following. Root 7 times root 15. Well, 7 times 15, let's have a look at what that equals to. 105. And that's it. Question B. Minus 3 times minus 9 is positive 27. Root 3 times root 11 is root 33. Okay, I can't simplify that surd. I can't split it into two numbers where one of the factors is a square number. So that is my final answer. Expand and simplify where necessary the following. So the same thing as before, minus root 5 times root 11 is just minus root 55. Minus root 5 times positive root 13 is minus root 65. Okay, none of these surds have a factor that is a square number, so that's our final answer. Question B. 5 times 2 is 10. Root 2 times root 13 is root 26. Five times minus 1 is minus 5. Root 2 times root 11 is root 22. Again, we can't split 26 or 22 into two numbers where one of them is a square number. Question C. Minus 2 times 2 is minus 4. Root 8 times root 2 is root 16. Minus 2 times minus 3 is positive 6. Root 8 times root 20 is root 160. Okay, 8 times 20 is 160. What's the square root of 16? The square root of 16 is 4. Therefore, we have minus 4 times 4, which is minus 16, plus. What can we split 160 into? Where one of the factors is a square number. Well, the highest number that I can think of that is a square number that is also a factor of 160 is 16. So I'm going to write down this 6 here. 6 times the square root of 16 times the square root of 10. What is the square root of 16? It's 4. So we have minus 16 plus 6 times 4 is 24, root 10. And that's it. Simplify the following. 2 root 7 all squared. That means 2 root 7 times 2 root 7. 2 times 2 is 4. Root 7 times root 7 is 7. So we got 4 times 7, which is 28. Question B. Here we have minus 3 root 2 times minus 3 root 2. Minus 3 times minus 3 is positive 9. Root 2 times root 2 is 2. 9 times 2 is 18. Last question. Root 2 times 3 is 3 root 2. Remember, it's not root 6 because that 3, this 3, is not underneath the square root sign. Root 2 times minus root 3 is minus root 6. Here we can multiply them because they're both underneath the square root sign. Minus root 8. We can split this root 8 into root 4 times root 2. So let's write that out. 3 root 2 minus root 6 minus root 4 times root 2. What is the square root of 4? The square root of 4 is 2. So we have 3 root 2 minus root 6 minus 2 root 2. Now we have like terms. 3 root 2 minus 2 root 2 is 1 root 2 minus root 6. And that's it for this video.